Okay, so what we're doing today is we're going to solve some quadratic equations. Now, there's three techniques that you're going to learn about. The first one is solving by factorising. So we need to be careful, not be careful, but consider when we're solving equations of the form ax squared plus bx plus c equals 0, be mindful of what the a's and the b's and the c's are. So the a's are always the coefficient of x squared, the b is the coefficient of x, and c is your constant. There will always be an x squared in it, that's what makes it a quadratic, but there may not be a b and there may not be a c. You can state those as being zeros if they're there, but we'll get to those sort of questions. So the first thing we're going to do is we're going to factorise. Now, when we factorise and solve quadratics, we're using the idea that if p times q equals 0, then either p equals 0 or q equals 0. So it's got to be equal to 0, it can't be equal to some other number. So you'll notice with most of these, they're always equal to 0. So we're using this property to try and solve them. Now, these ones have already been factorised. So I'm going to show you something now, and then we'll get into factorising some quadratics and using this idea. So if 4w times 3w plus 2 is equal to 0, then either 4w equals 0 or 3w plus 2 equals 0. Now, you can write them both down like that. I always put an or in the middle. You don't probably need to do that. But these two equations are easy to solve. They're linear, and you're used to solving those. So this one here, to get the w by itself, you divide both sides by 4. Now, 0 divided by 4 is just 0. So what that means is that 0 is a solution to this quadratic equation, which has already been factorised for us. This one over here is a little bit harder, but it's pretty easy once you know it's just a linear equation. Move the plus 2 over, becomes a minus 2. Or subtract 2 from both sides. Divide both sides by 3. And you get your other answer. The beauty of equations is that you can always check your answers by substituting back in and see if they work. So if you've got a bit of time up your sleeve, check that 0 works, check that minus 2 on 3 works. So if you put minus 2 on 3 in here, 4 times minus 2 on 3 times 3 times minus 2 on 3 plus 2, press equals, it should be equal to 0. And if it is, then you've done it right. This is the same idea, just a little bit different. We know that 5m plus 2 times 2m minus 7 equals 0. So that means either 5m plus 2 equals 0 or 2m minus 7 equals 0. So solving this equation here, we take the plus 2 out of the other side, becomes a minus 2, and then we divide by 5. This one over here, we move the 7 over, becomes a plus 7, divide by 2, we get 7 on 2. Again, you can check them if you like, but you might be in a bit of a time poor in your exam, so you might just keep moving. A couple of things, try and keep your equal signs underneath each other. That's pretty close, but not great. And just write both of them next to each other if you've got space, or one under the other. So let's move down to these ones here where we actually have to do some factorising. So when you factorise quadratics, you've got to use those different strategies. So in this one here, this is a fairly easy one because we just need to take out the highest common factor. So we take out probably a 3p, because there's a 3 in both of those and a p in both of those. If you take a 3p out of the first one, 3p times 2p gives you the 6p squared. If you take a 3p out of that, we go with a minus 3. Now this question now is exactly like this one up here. Either the 3p equals 0 or 2p minus 3 equals 0, and we just solve those two. So divide both sides by 3, we get a 0. Move the 3 over the other side. When I line up these equal signs, that looks stupid because they've got a big gap, so I tend to just write it next to each other, as long as it goes down the page, and that's 3 on 2. So they're your two answers to that. Now, you can always check the 0, like 0 into here, 6 times 0 squared minus 9 times 0 is 0, which equals 0. You can check the 3 on 2 as well, but you probably use a calculator. Now this is one that's a little bit harder to factorise. I probably should have put an easier quadratic to factorise, but we've done an awful lot of those. So this is one where we would have to use a different strategy to factorise. Now because it's got a 2, this is what we call a non-monic quadratic trinomial. So we've got to use crossbones, or that technique that some of you use of splitting that middle term and grouping by pairs, whichever one you're most comfortable with. So I'm looking for two numbers, I do crossbones, two numbers that multiply together give you 2x squared, so that's a 2x and an x. And two numbers that multiply together give you 15. So I'm thinking of 3 and 5. If I put a 3 there and a 5 there, I know I'm going to get pretty close to this 1 here. I just need to be careful with my sign now. So I know one of these has to be a negative because their product is minus 15, so I'm going to put a negative there. The reason I put that there is because, well, actually, no, I put it in the wrong spot, but I'll show you why. Let's put the negative there and just test it. So 2x times 3 is 6x. X times minus 5 is minus 5x. When you add those together, you get an x. Now, we're not after x, we're after minus x. So because I've got the right term here but the wrong sign, just means that negative needs to be down there. So when I go that times that, it's a minus 6x. That times that is a positive 5x. When you add those together, you get minus x. Now, that needs to be that term in the middle. So now we've got it in factored form. So 2x plus 5, x minus 3 equals 0. And we go through the process of saying either this has to equal 0, so 2x plus 5 equals 0, or x minus 3 equals 0. Move the 5, becomes a minus 5, divide by 2, There's one answer. The other answer is x equals 3. So that's a pretty easy one to test. If you put a 3 in here, you get 2 times 9 is 18. 18 minus 3 is 15. 15 minus 15 is 0. So we know that one works, and we should be confident with that one. This one over here, all we need to do is make it look like one of these. You just got to move everything on the other side and make it equal to 0. So 6y squared plus 7y minus 5 equals 0. Again, this is one where you're going to have to probably use crossbones or split the middle term so you can group by pairs. So I'm going to start with 3y and 2y, and then I'm going to have to go a 5 and a 1. Now I'm going to put a 5 there and a 1 there, because that'll give me 10, that'll give me 3. Now I reckon I can use the 10 and the 3 to get me a 7. Now the fact that this is a negative means that one of these needs to be a negative, but their addition needs to be a positive. So the bigger one will be a positive, the smaller one will be a negative, so we can put that there. And you can test it. That times that's minus 3y, that times that is 10y. When you add them together, you get 7y. So that's the term in the middle. So I get a 3y plus 5, bracket 2y minus 1 equals 0. So 3y plus 5 equals 0. Take the 5 over, becomes a minus 5 divided by 3. And 2y minus 1 equals 0. 2y equals 1, y equals a half. So that's how you factorise quadratics. I've seen this an awful lot. Don't get into this habit. See people do this. So they go 2y squared minus y equals 6. Rather than taking the 6 over and making it equal to 0, people want to do this. They want to go y, 2y minus 1 equals 6, and they get a little bit stuck because you don't have a rule which says some number multiplied by another number equals 6. We have something when it's equal to 0, but it's the only one. So don't do it like that. That's one of the common mistakes you'll make. Make sure you kick it over, make it a plus 6, and then you can factorise when it's equal to 0 and solve it. Okay, good luck.